Hello students, welcome to the topic analysis of univariate data. It is presented by Shantala Kulkarni, Department of Statistics, Gokti BU College of Commerce and Science, Belgavi. So in the previous class, we have finished with the formulae of median and also the formulae of arithmetic mean in the previous class. In today's class, we will be dealing what is the meaning of mode and how and what are the different formulas of mode. So the definition of mode is, it is the value which occurs most frequently in a set of observations and around which there is maximum concentration of values. It is denoted by capital Z or Z. So it is the most typical of fashionable values of the series. Now consider the statement average collar size is 35 centimeters or average shoes size is 7 inches. Here the average implies mode, that is the modal statement. So mode is nothing but the one which has got the maximum repetitions or the maximum frequency, one which keeps on repeating again and again. So if you go to the market, the average size of footwear is 7, or the average clothing which goes in the market is M size. So the one which goes is sold the maximum, that is the mode. Now we will see what is the formula for computation of mode. See, actually for ungrouped data and as well as for discrete data, you don't have the formula for mode. You have formula only for the continuous data, that is if the class interval is there and the frequency is there, then only you have to remember the formula. But otherwise for ungrouped data or raw group data or as well as discrete data, just by mere observation you can find the value of mode. So for the first one, ungrouped data, it is found mere by inspection. For example, let us take this example. Marks of students is 25, 32, 35, 45, 49, 35, 35. Now which is a value which is appearing the maximum number of times? Which one is that? So the value which is repeating maximum number of time is 35. So here the value of mode is 35. Clear? Next example, height of 6 students, that is 165.2, 165.8, 171.2, 172.3, 165.2, 171.2. Here the distribution is bimodal. Now if you observe, so 165.2 and 165.2 is repeated twice, as well as 171.2 and 171.2 is repeated twice. So when the mode value is repeated 2 times, we call it as bimodal. There are 2 modes for the distribution. Similarly, we can come across multimodal distribution. In such cases, we say that mode is ill-defined. If it crosses more than 2 or usually bimodal it becomes very difficult to calculate where the data is having 2 modes. So if it is more than 2 mode, we say that mode is ill-defined. There cannot be mode. It has to be only one value. To be very specific and to be very clear, the distribution has to have only one mode. And for grouped data, see now for group data also, group data is divided into discrete and continuous. For discrete also you don't have the formula for mode. Z is equal to value of x corresponding to the highest frequency. For example, now x value is there, f value is there, x is 2, 3, 4, 6, and here the mode value of f frequency is 6, 8, 9, 2. Among these frequency values, the highest value is 9. So the corresponding value to the frequency, highest value frequency is 4. So this mode is equal to 4. We will solve examples on that. I am just explaining to you all. We will see what is the formula for continuous data. The formula for continuous data is Z is equal to L plus bracket Fm minus F1 divided by 2Fm minus F1 minus F2 into C. Now we will see what these terms mean and what are the steps you have to remember. So the first step is to identify the highest frequency. Okay, after you identify the highest frequency, you have to see it is lying in which class, or it is also called as the modal class. Then you apply this formula. What are these terms representing? C is width of the modal class, means for example 25 to 30, the width will be 30. If it is exclusive, you are going to, you should know how to calculate the width of exclusive and inclusive class interval. Then L is the lower limit of the modal class. F1 is the frequency preceding the modal class, means before. Then F2 is after, and Fm is the frequency of the modal class. Then we will see empirical relation among mean, median, mode. Means there is a relation, actually there is an experimental relation between mean, median and mode also. Now in a symmetrical distribution, mean, median and mode have the same values, but in actual life most of the distributions are asymmetrical, skewed. In case of moderately skewed distribution, the value of mean, median and mode have the following relation given by Carl Pearson. And what is that relation here? Mode is equal to 3 median minus 2 mean, and we are writing that in the form of shortcut here. Now first, what is the meaning of symmetrical and asymmetrical? Symmetrical means any diagram when you draw or cut it into equal parts. Those, for example, see, this square is symmetrical. This particular diagram I am telling, when you divide this into two, this and this part when you match together, they are symmetrical in nature, right? Now for example, one more example now, if I give you the diagram of those, for example, I am not getting which one. If you divide them into two equal parts, both the parts are not equal, so that is asymmetrical. So this particular word what we use, or what you call it as symmetrical, most of the time it is asymmetrical and sometimes it is symmetrical. So empirical relation among mean, median and mode, we are using this particular formula. You only remember this because there is again a separate topic on moment, skewness and kurtosis. So if I explain about skewness, if I explain about symmetry or whatever it is, you people are not going to understand it right now. So you just remember right now for you all is the empirical relation between mean, median and mode is to remember this particular thing. That's it. Only you remember this part. The symmetrical, non-symmetrical, skewed, moderately skewed, everything will be taken care in the future classes where I will be explaining everything in detail. Next, graphical solution. As you have already seen that mode can be obtained graphically with the graph histogram. You have seen that in graph section. So remember, the value of mode can be graphically found by representing the distribution by histogram. And you know the process and all that, it's only given here, that's all. Next, we are going to see the merits and demerits of mode. What are the merits and demerits of mode? The first one, it is easy to understand and simple to calculate. If you observe, all the first merit points are the one and the same only, little bit changes here and there. Second, it is not affected by abnormal extreme values, because it's, true. You're choosing mode value as the one which is repeating the maximum number of times. Third, it can be easily calculated for open and class intervals. Very true. Then fourth, it can be graphically found. These are the advantages or the merits of mode. We will see what are the demerits. It is not based on all the values, because it is not covering all the values. It is taking only one value which is repeating maximum number of time. Second, it is not as stable as arithmetic mean. Yes. Then third, it is not rigidly defined. It means if you want to have more accuracy in the data, or if you want to have more accuracy in the analysis, you want something very, very perfect result, there you cannot apply the formula of mode, because it is giving very superficial value. But on the contrary, mean is the one which is taking all the data into consideration. So here in statistics, what is important? We are going to analyze everything in detail, depending on the situation, depending on the requirement, formulas are being used. But if you observe, for example, if you have to tell your percentage, if you have to tell the height of your class, or if you have to tell the percentage of your whole class, you will be taking the percentage values of each and every student. For example, 1A class, there are 100 students. When all the 100 students are present, then only the class is complete. Suppose if there are 2 students are absent or 5 students are absent, that doesn't mean that the class is complete. It is incomplete. It will be complete only when all the 100 students of that particular divisions are present. So this is the meaning of not rigidly defined or taking all the values into consideration. So in today's class, I just explained the definition of mode, then the formula for mode for ungrouped data as well as for group data. Remember, you only have to remember the formula for mode for the continuous data. For discrete also, it is just by observation you can find the value of mode, and for ungrouped or raw data, what we call, there also you can find the value of mode by just observation. So for today's class, that's it. Thank you children. If you have any doubts, let me know. See you in the next class.